Okay, Assalamualaikum class. So now let's continue on the phasor relationship in the circuits elements. Okay, so the one that you have learned before is what is sinusoid and what is phasor is Vm with the angle. What is sinusoid is Vm, V equal Vm sine omega t plus the phase, right? And now we move to what is the relationship with this RLC in the phasor form. So when we are talking about circuit elements, you learned in the previous chapter that is resistor, and I will introduce to another element that is called inductor and capacitor. So all these are passive elements. So resistor is to limit the current flow. So what is the function of the inductor and capacitor is to store the energy in terms of the voltage. Okay. So beside resistor, so you will learn about inductor and capacitor, and both are in a linear form. So what does that mean by linear form? So let's say this is a resistor. So this is a linear, okay? Linear. When voltage increase, the current also increase. And all are passive element where they cannot supply energy, they can transfer the energy. So both L and C is for the storage. Okay. So let's see the first one. What is capacitor? So capacitor is a two parallel plate. Both are dielectric. Okay. So when you put it together with a certain distance, when you apply a voltage connected to the top and the below plate, okay, so it will be able to store the charge, to store the energy in terms of charge. Okay, so the capacitor consists of two conducting plates. So it is separated by what? It is separated by an insulator. So in the middle one is an insulator. So the distance play role. Okay, so we have a parallel conducting plate. So the above and one is need to be conductive. Okay, so what is the unit of the capacitor is denoted by this one. So capacitor has polarity. So here is plus and here is minus. And the current will flow across the capacitor. So what is actually capacitor? So just now I say capacitor is two parallel plate. So when you connect to the power supply, the voltage, it will accumulate the charge at the conductive plate. So the separation of this charge will allow it to store the charge. Okay. So the first formula is Q equals CV. So Q is the charge. Where from this charge you are going to get the current, right? So because what is current? Current is the dq over dt, the change of the charge movement by time. And C is the capacitance. So capacitance is in farad and V is the voltage in volt. So this is the first formula, Q equals CV. So but what is the capacitance? So capacitance denoted by the permittivity multiplied by the area. So what is the area here? The area of this conductive plate. How we calculate the area of the conductive plate? X times Y, right? So A over D. So what is D? D is the distance between two parallel plates. So this is the capacitor. The connection, the distance between the top and the below plate is called the D, the length. Okay. So this is how you calculate the capacitor. It is in farad. And this is a permittivity, area, and the length. So, in the capacitor, so we want to see what is the relation of the current to the capacitor. Okay, so the first formula is Q equal to CV. Q by time is equal to C by time. If you differentiate this Q, and you need to differentiate also the left part, CVT. Okay, so what is dQ over dt? This is current, IT, right? I equal dQ over dt. C is a constant, so you take out, it become dV over dt. So you can denote what is I? I is equal to the capacitance multiplied by the differentiation of the voltage. This is how you can get the relation between the current and also the voltage in terms of capacitance. Okay, so this is the same. Okay, so let's see what is the voltage relationship. So you know just now, so what is the formula? I equals C dV over dt. So you want to know what is the relation of V to I. So you just make it I divided by C. Okay. So you want to find the V. So means you need to integrate I over C dt, right? So C is a constant. You take out the 1 over C. So you're going to integrate I dt at initial time to the time taken plus the initial value. So this is how you get the relation of the voltage towards the capacitance. So how you calculate the power? P equal to VI. So you know I is equal to C dV dt, and then you can get P equal C dV dt, C dV dt multiplied by V. So this is the instantaneous power. Okay. So as a summary, what is charge? Q equal to CV, I equal C dV dt. What is V? 1 over C integrate I dt plus initial time. So that's all about inductor. Now what is capacitor? It is also a passive element. Just now our capacitor store the electrical energy in a form of charge, right? But now the inductor is store electrical energy in the form of magnetic. So when we're talking about magnetic, we need to have what we call coil. So the conductor is worn into the coil. So this is a coil, need to be conductive, and then it will create a magnetic field. So this is a figure of a magnetic field. So when you have a coil from left to right, so it will generate the magnetic field from left to right, and the current will flow accordingly. Okay, so this is just a formula of L. Mu, the magnetic permittivity. K is Nagoka function, number of turn of the coil, cross section of the coil, and the length of the coil. So this is just for your information. Okay, now let's see the formula. So now you want to find the voltage across the inductor. So the formula is V equal to L di over dt. For the capacitor just now is current, right? I equals C dV over dt. So how do you represent the inductor? It's in the form like a coil, L, and the current flow here, and this is the voltage drop in the inductor. Okay, so let's see the formula. This is the summary. Resistor is V equal IR. This is Ohm's law. Inductor is V equal L. You differentiate the current, and the capacitor is I equal C. You differentiate the voltage. So this is the relationship of the voltage and current inside the R, L, and C. Okay, now so we're going to see from that what is the relation between this impedance and admittance. Okay, as you learned before, this is the sinusoid form. This is a phasor form. If you differentiate, you're going to add here j omega, right, in the phasor form multiplied by V. But if you integrate, you're going to divide by j omega, and this is your function. Okay, so let's relate to the inductor L. So what is the formula for L? V equal L di d small I di over dt. So if you want to change this one to the phasor form, this is a bold V equal L is a constant, right? And this is a differentiation, so you need to multiply by j omega. So what is the function here? I. So you can get V equal j omega. So it's the same j omega L I. Right? So this is in the frequency domain. How about the capacitor? So you know the formula of the capacitor is I equals C dV over dt. So let's transform to the I. So become I here is equal to C. Now it is a differentiation, right? So become j omega J omega V. So if we want to know in terms of the voltage, is actually I over J omega C. So this is how you present in the phasor domain or frequency domain. So for the capacitor, V equal I over 1 over J omega C. For the inductor, V equal J omega Li. And for the resistor, it's just V equal Ri. So this is the relationship between the phasor and the circuit element. Okay. So this is the presentation for the resistor. So you have the resistor here. This is a time domain, sinusoid. And this is the phasor domain. So this one need to be bold, right? So V equal IR. So it is, there is no lead and lag. V and I is linear at the same, it's what we call same phase. Okay. How about inductor? So you represent this one as the inductor. And you know the formula is V equal L equal di over dt. You transform to the phasor like previous slide just now. Then you can get, this is the phasor form. V equal J omega L. So see the figure. This is a complex number, right? So you remember this one. Ellie the Iceman. Represent E here as a voltage. Okay. If it is inductor, L is the inductor. Your voltage, E is a voltage, will leads current. So if you see this figure, the voltage will leads the current. Voltage come earlier, right? Voltage will leads the current. How about the capacitor? And then you can represent this as a capacitor. You know the formula is I equals C dV dt. In sinusoid, you transform to the phasor. I equal J omega CV, like in the previous slide, right? And then Iceman, this is a capacitor. So current leads, E is the voltage. So you can see current leads voltage. Okay. So this is a relation. So in the next video, we will see how these relate to what we call impedance. Impedance consists of denoted by Z and the admittance denoted by Y. Okay. So see you in the next video. Assalamualaikum.